Hello and welcome to today's talk on which NoSQL database is right for you. I'm Jason Hunter. I'm a principal solution architect with AWS with a particular focus in NoSQL and DynamoDB especially. I've been doing NoSQL databases for almost 20 years now. So this is a topic near and dear to my heart. And I'm here with Siva. Siva, can you introduce yourself?
Hello there. This is Siva Karturi. I'm a specialist SA for in-memory databases, which is also a subset of NoSQL databases. I've been doing this for almost 10 years, done Couchbase, done Cassandra, MongoDB, you name it. And here I would be doing mostly the in-memory databases.
All right, so I think you guys are in good hands. What we're going to talk about today is the idea of purpose-built databases, why you would pick that instead of just maybe just choosing a relational database for anything and everything. And there's a different set of flavors of these things. There's some in-memory and key value and document. We're going to cover that. And we'll look at each of these particular service offerings and what they offer, how they're different from each other. And then we'll end with kind of a quiz, so pay attention. All right, I have a situation like this, or I'm presented with this problem. What of that would make me want to pick one database service over another, right? This is a spectrum of different purpose-built databases that you can use, from relational on the left, key value, and some in-memory, document-oriented, cache-oriented, graph, where you have nodes and you're wanting to wander around on the graph to do graph-oriented queries, time series, ledger, kind of blockchain, as well as wide column, which is similar in some ways to document in memory, but still a little bit different. And we're going to focus on 4 of these particularly today: the MemoryDB, ElastiCache, DocumentDB, and DynamoDB. This is kind of a quick summary of what we're going to cover today. They're all managed. Some of them are serverless. They all have immense scale. They scale in different ways, though. And they have different APIs, which can help you choose which one you'd want if it's important to you to have a particular API over another API. And these are largely in the key value, in-memory, and document database styles, different categories. The idea being not every problem in a database context should be solved with the same tool, right? There's a reason for a screwdriver. There's a reason for a wrench. There's a reason for a hammer. We have purpose-built workshop tools. We similarly have purpose-built database tools. So that's what we're going to talk about today. I'll hand it over to Siva to get us started with MemoryDB.
Thanks, Jason. In talking about in-memory databases, let's talk about Amazon MemoryDB. This is one of the 2 NoSQL in-memory databases supported by AWS. When we talk about in-memory databases, what's driving this is mostly around the move towards modern application architectures, which is mostly event-driven microservices-based architectures. That requires that you decentralize, you have event-driven architecture. And what's driving this is mostly about personalization, the move where the modern applications are doing a lot of millions of users with high throughput requirements. MemoryDB for Redis was designed based on these principles. Where you can access data out of memory pretty fast with very low latencies. MemoryDB for Redis is also fully managed and highly durable with data spanning across multiple AZs. It also has compatibility with Redis, open source Redis, which means that you can build applications pretty quickly through the flexible API. And it can handle millions of requests per second. Now, in terms of manageability, it's fully managed. You can quickly launch the clusters either through CLI and the console or using the CloudFormation templates. You can automatically upgrade your clusters. Most of your patching is handled by MemoryDB. And then it has integration with other AWS services like CloudWatch, CloudTrail, monitoring through SNS, security, and so on and so forth. In terms of scalability, this is the most important feature of MemoryDB, is the ability to scale horizontally or vertically. You can scale up to 500 shards, and each primary node can have up to 5 replicas. So this gives you the ability to scale up to 100 terabytes in single cluster. all the while during scaling operations, the cluster continues to stay online and support your read and write operations. Moving on into replication, this is one of the features where your replication is the data between the primary and the replicas is done through the durable multi-AZ transaction log. What that means is that as your primary takes the reads and writes, it gets written to the transaction log before acknowledging the write back to the application. So this means that all the replication, once it's written to the transaction log, gets replicated to the replicas with zero data loss. As far as indexing is concerned, Redis flexible data structures gives you the ability to create secondary indexes on top of your primary level attributes, which is great because not only it's just a key value data store, you can create complex queries on top of your basic key operations. In terms of streaming, this is one of the features widely used, the Redis streams, and the ability to stream your data across multiple use cases or even multiple applications. Supportability for ACID is pretty strong in the sense that it has a strong read after write consistency on primaries and eventual consistency on the replicas. So this gives you the flexibility to choose both the consistency options. In terms of durability, it's got the multi-AZ transaction log and it's highly durable with zero data loss. In terms of the way you can access MemoryDB, the schema is primarily driven by the Redis APIs. So even though it's a key value data store, it's not simply a key value operation anymore. You can leverage a lot of the data structures that Redis provides, like the streams, sets, lists, so on and so forth. So this gives you the flexibility to model your applications based on your data access patterns. In terms of connectivity, primarily you can access it from within the VPC using the cluster endpoint, but if you need to separate out your applications in a separate VPC, you can do peering, and it also supports connectivity through VPN and Direct Connect. In terms of pricing, there are three main components to the MemoryDB pricing. One is for the node itself, which is charged per instance hour. Then the second component is about data written to the MemoryDB cluster, charged per DB. Finally, the snapshot storage as well, charged per GB per month. For more details on pricing, you can please look at our website, the MemoryDB pricing page. In terms of the use cases, most of the use cases are driven by high performance, and most of the applications, the modern applications that you can think of, they are driven by highly personalized customer profiles, inventory tracking for retail, for instance, web and mobile. This is one of the most popular use cases for MemoryDB, where you can do highly durable session stores, whether it is chat and messaging queues, geospatial indexing, and so on and so forth. Gaming also is pretty popular set of use cases for MemoryDB as well, whether it is having a durable session or a leaderboard, so on and so forth. We are also venturing into banking and finance, where if you need your transactions to be highly durable, you can have MemoryDB as a primary database. In terms of customer stories, one of the popular, like I mentioned earlier, MemoryDB was designed for event-driven microservices-based architectures. And one of our earlier customers, Netflix, saw our architecture and worked with us in developing the MemoryDB, the highly durable store. And they had this use case of basically having all these events, store them in MemoryDB, and then use those events for their microservices. One other use case that we can think of in the financial services industry is the payment processing, where security, making sure the user data is highly secure. So one of the ways of doing that is using tokenization. So every single API click is tokenized and stored in MemoryDB, and then later on used in all the other applications. The solution was basically store them in MemoryDB, and since MemoryDB provides ultra high performance with low latencies, it was an obvious choice for them to implement this particular application. Some other customers, Simpress, Transact, Integral, most of these use cases are available on website. You can check them out. So just to summarize again, MemoryDB is a fully managed, durable in-memory database service, and it was designed to deliver ultra-fast performance, single-digit millisecond writes, sub-millisecond reads for up to 160 million TPS per cluster. MemoryDB, you can also leverage Redis APIs to flexibly build your applications. It's highly durable, so you can consolidate your data stack. You don't need to have a separate cache or a primary database. You can use MemoryDB as a primary database. It provides strong read after write consistency on the primary nodes, which is also great. For use cases that require high consistency, you can definitely leverage MemoryDB. It also is highly available with auto failovers. So for applications, you don't need to worry about downtime. And finally, you can scale pretty well with MemoryDB as well. Now, moving on to the closer twin of MemoryDB, it's Amazon ElastiCache. It is powered by two open source Redis engines, Redis and Memcached. It's a fully managed service, just like MemoryDB, provides extreme performance. The only slight difference between MemoryDB and ElastiCache is that ElastiCache does not have the durability. So if you're thinking about use cases where durability is not a requirement, you can think of ElastiCache because it's slightly cheaper, and at the same time, it gives you even better performance than MemoryDB. It is secure, it's highly reliable, it's compliant with all the standard HIPAA, PCI, FedRAMP, and finally, it can scale pretty well for both your reads and writes. Amazon ElastiCache for Redis, like I mentioned earlier, it is powered by two popular open source engines. For the sake of this discussion today, we're going to focus on Redis. Again, it's available in all the available AWS regions. It has multi-AZ with auto failover, which means that it's got the ability to failover to a different availability zone. And the event, let's say you have a failure in a particular AZ, you also can replicate across regions using a global data store. You can scale up to 500 nodes per cluster, up to 340 terabytes. We also have an extra feature called data tiering, the ability to expand your storage capacity, which means that you don't necessarily have to store your entire data set in memory. You can leverage the SSDs or NVMEs to expand your storage. Finally, we have support for snapshots, and it operates in multiple configurations. You can have a sharded configuration or basically a non-sharded configuration where you just have a single primary and up to 5 read replicas. In terms of the standard features that ElastiCache provides, it provides the same basic features as MemoryDB, but it's got an extra feature about a global data store where you can actually replicate your data across regions. But in terms of the basic replication, the replication happens from the primaries to the read replicas. It's an asynchronous replication between the primary and the replicas. Storage, like I mentioned, it's going to be, we can leverage data tiering to expand your storage. Indexing, you can leverage the same Redis data structures to create secondary indexes for your queries. You can use the same Redis streams for data streaming, and the ACID transactions remains the same. In terms of manageability, I would still say that it is similar to MemoryDB in terms of the manageability, where you can leverage different ways to spin up your clusters from CLI to SDK, CloudFormation. You can also leverage the fully managed ElastiCache to keep your clusters up to date. Integration, from an integration standpoint, just like any other AWS service, you can integrate that with CloudWatch, CloudTrail, VPC, so on and so forth. Scalability, You can do both horizontal and vertical scaling depending upon which mode of ElastiCache you operate on. For instance, in a cluster mode enabled, you can typically do both horizontal and vertical scaling. But in the cluster mode disabled, since you only have one single primary and up to 5 read replicas, you can do vertical scaling for most part, but you have the flexibility to scale horizontally for your read replicas. One of the latest features of ElastiCache is the ability to auto-scale based upon predefined rules using your CloudWatch metrics. You can also scale up to 500 shards, just like MemoryDB. The storage capacity is a little bit better, up to 340 terabytes. And all during the scaling operations, your cluster continues to stay online and support your applications. It has the same Redis APIs, like I mentioned earlier with MemoryDB, and you have the ability to flexibly develop your applications. And the connectivity remains the same as MemoryDB. You can use the cluster endpoint from within the VPC, and you can use VPC peering if you have your application outside of the VPC. The pricing and competition, in terms of pricing, again, you pay for the on-demand instance and the node type. You also pay for the data transfer across your AZs, and also you pay for the backup and storage. For details on pricing, please check up our website. The use cases, again, this is where there's a lot of confusion about when to use ElastiCache or MemoryDB. The primary classification is the data durability requirement. If you're dealing with ephemeral data, then ElastiCache would be the preference because ElastiCache does not inherently have the multi-AZ transaction log to store your data. So the popular use cases are mostly caching, caching in front of your relational database or any other database like DynamoDB. You can use ElastiCache for leaderboards, which is a very popular use case in the gaming industry that uses ElastiCache, and chat applications or session stores are the other use cases. For the customer story, this is pretty interesting. Leaderboards, we talked about leaderboards, but the ability to provide low latency real-time processing of the data, where each of the rider gets personalized data, and the ability to create your scores in real time was built on ElastiCache. And ElastiCache provides you the scale to millions of ops per second. In this particular case, it was around 20K requests per second, and it was cached in front of RDS MySQL. These are some of the other customers that ElastiCache continues to enjoy. And in terms of summary, it's fully managed, and it is not a complete database by itself. It's typically used as a caching service on top of other primary database. It can leverage the flexible Redis APIs. ElastiCache has a second engine, like I mentioned earlier, it's Memcached. So you will be able to leverage both, but Redis, due to the flexible nature of its APIs, is the most popular one. It provides strong consistency in the primary nodes. And in terms of high availability architecture, it has a multi-AZ with auto failover. You can also replicate across multiple regions. The scalability is also pretty high. And then to cut down your cost, to optimize your costs, you can leverage the data tiering feature to expand your storage beyond memory. Finally, just to sum this up, we introduced JSON pretty recently. Up until this point, whenever you had to use Redis, you had to use a couple of other data structures where you just use strings, and it was a big hassle because it does not natively support JSON structures. So the applications had to basically find a way to serialize and deserialize the data before accessing it. So out of popular request from a lot of our customers, we had to go and basically build a separate data type called JSON data type for Redis, the ability to basically use JSON in its native form. No more serializing and deserializing of your data. You can use standard commands just like you use with any other Redis data structures. This is huge because now this expands a whole set of use cases beyond what Redis already provides. So the JSON data type that I mentioned earlier gives you an additional set of commands for manipulating your JSON structures. It's basically, you can go up to a whole bunch of levels to basically access your JSON structures from within your JSON key value pair. With that, I want to return this back to Jason for an overview on DynamoDB and DocumentDB.
All right, thank you, Siva. And let's get started talking about DynamoDB. DynamoDB is distinct in that it's serverless. And what that means is you never think about the number of servers. There's no primary server. There's no sizing of servers or anything like that. It is to you just like a web endpoint behind which the magic happens. It is in some ways kind of like a google.com request. I assume Google runs servers behind there when they answer my searches, but I don't know how many. It doesn't worry me that they maintain that. That's what this is for you. It's a database where you make your requests, you put your data in, you retrieve it. You don't even understand on the back end that there are servers. And as a result, you get 4 nines availability or 5 nines if you use global tables without any real database operational duties that fall on you. There's not a version to upgrade. There's no maintenance windows, anything like that. As a result, because it runs on many thousands of servers inside the AWS environment, you get virtually unlimited scaling. With Amazon.com, I'll talk about it, peaked at 89 million requests per second during Prime Day. And I've done databases a long time, and 89 million requests per second still makes my eyes pop out a little bit. So you have to be aware of how it works. You have to be aware that there's this thing called a partition key. But if you do a good job in designing your data model and your partition keys, it will scale automatically up and down. It can scale down to 0, and you don't get any throughput charges. And then you can, the next second, scale to 2x your past peak, and it'll still be able to handle all that traffic. So you can go from 0 to 1 million requests per second, literally that fast. If the table has previously been scaled up to get 500,000, you could jump to 1 million after being at 0 the time before that. So this is kind of distinct, kind of unique in the database world, I think. Some of its differentiating features on top of that serverless nature, one is global replication. So you can replicate from one region to another, and you can write and read to any of the regions. They're all equivalent. There's no primary and replica. They're always replicating to each other. That's great for situations where you want low latency for your users. And so based on where they are geographically and where the lowest latency would be, they can read and write to their local copy, and yet it replicates to all the other environments. It also gives you disaster recovery. Should a region be out, they can, in fact, you can just move to another region that was already taking all the read and write traffic. So you're not thinking, oh, I have to promote this to being a primary system. It was already primary before. It also, from an indexing point of view, it's a strength, but it is somewhat limited. So you want to be aware of that. It has a partition key and a sort key. That's what you get. And you can have global secondary indexes to provide a different point of view on the same data. But some things it doesn't do. It doesn't do like a text search. It doesn't do geospatial out of the box, things like that. That's why we call it a key value store, because it's primarily for lookup by key or by key and a scalar value. That is your primary lookup. It's very fast at doing that, but you can't give it unbounded work. You can't say, hey, give me, let me constrain by these 5 arbitrary things and sort by this extra attribute. That's not a kind of DynamoDB strength. It does have change data capture, where you can watch for mutation events that happen on the table using either DynamoDB streams or Kinesis data streams. And with built-in Lambda support, you can say, invoke this Lambda anytime something changes in my database, and you can propagate the data to some downstream system. You can keep a scoreboard in the database for counts or other analytics that you want to have readily available for later queries, things like that. And it's real simple with Lambda. In fact, one of the perks of DynamoDB is its deep integration in the AWS environment. And it actually does have ACID transactions. Up to 25 items, you can say, do these, and I want it to be atomic. I need them all to update or none at all. And that's great. And it even works across tables. From a schema point of view, it's immensely flexible. The only thing you have to define when you create the table is the partition key and the sort key. Everything else is ad hoc. And one of the designs that is popular is called single table design, where you put different entity types in the same table, which can be strange if you're coming from a relational mindset where every table has a particular entity type associated with it. But if you can put multiple types in the same table, you can retrieve all sorts of data with one singular wire request. Very cost effective, very efficient to be able to do that. And so the ability to have different items in the table with different attributes is immensely beneficial when you're really trying to work on performance and scale. The API is pretty straightforward. You get an item, you put an item, you do a query where you specify a partition key and some sort of sort key constraint to pull out items that match, or a scan where you brute force scan the table. And that's nice to have a scan, but be aware when you're doing it that you're scanning a whole table. If you can express something with the API, it basically will execute quickly. That's kind of great, actually. You don't have to think, all right, what's the query optimizer doing on the back end? Is this going to run well? Is it going to scale? If you can express it, it's going to scale. So what you do then is when you design your data model, you make sure that you can express everything that you need to express. As a result, it will scale, it will be fast, and it will scale as large as you need. And there's a huge number of client languages. It's available in all sorts of regions. It has a public endpoint, but I would recommend looking into the VPC gateway endpoint if you want private connectivity. It keeps it on the private network and also reduces outbound data charges because you're staying on the private network. So something to be aware of if you're using DynamoDB already. Think, should I be setting up a VPC gateway? You don't need one, but it's nice to have. Pricing is done in storage in gigabyte months. So you figure out how many gigabytes you have on average over that month, and there's a charge for that. And then reads, which is in 4K blocks, as you go in and read your items. If you read an individual item and it's 7K, that costs 2 read units. If you write 7K, it would cost 7 write units because writes are in 1K blocks. If you enable eventual consistency, it's half charged. And because of how it works on the back end, there are 3 nodes that are saving your data for high availability. If you turn on eventual consistency, it will go to any one of them. Anytime you do a write, it will always write to 2 of them, and the third one will quickly catch up. If you do eventual consistency, you might 1/3 of the time be going to the one that is catching up. And so you might see stale data, but if that's okay with your application, half cost, that's fantastic. How do you pay for a serverless database? Well, there's 2 ways. One is on demand, which is pay by request. You just count the requests you made that day and you multiply it by the cost for each request. Real simple, goes from 0 to spikes, and it doesn't matter. It's just the number of requests made that day. Or provisioned. With provisioned, it's good when you have a more steady state. You basically say, I intend to use about this much. And so long as you're using that or less, it's more cost effective than on demand because you're giving the database a hint of the consumption rate. So it's kind of like, a subscription plan where you say, I want to use this much. It's more like that. We're all used to that in the world. And something to be aware of if you're a DynamoDB user, there are reserved capacity features which give you a discount. Over 50% for an annual, over 77% for a 3-year commitment. You specify, I will use at least this much, and as a result, you get a discount. So one thing I wanted to make you aware of. Use cases, lots of different verticals use DynamoDB. You probably use DynamoDB all day, whether or not you're aware of it. If you're doing something with banking and you're doing user transactions or any fraud detection, anytime you do a credit card charge, probably DynamoDB is involved. If you're doing gaming and you want to keep track of the game state or a leaderboard, probably using DynamoDB. If you're doing ride tracking, your Ubers and Lyfts, it's going in DynamoDB. You have to keep track of where's every driver, where's every passenger, what's the trip right now. A lot of reads and writes, low latency. That's a good use case for DynamoDB. And ad tech, I got to place an ad for this person. I have very strict latency requirements to pick the ad. DynamoDB is a good fit. Retail shopping carts, that's where this was born. Amazon.com first created DynamoDB to support the shopping cart of the retail site, and it's still used there. So, I want to be able to get and put items in a user shopping cart at immense scale with guaranteed low latency. Good fit. Or for media and entertainment, anytime you're watching video streaming and when you come back to it, it remembers where you were. Where's that state maintained? That state is very likely maintained in DynamoDB if you're using one of the primary streaming services. So let me give a use case of Amazon.com. So, Prime Day, it's lots and lots of traffic to Amazon.com. And in the 2021 Prime Day, there were 89.2 million requests per second made at the peak, trillions of API calls made throughout the Prime Day 66-hour time period. That's a lot of requests. And if you're going to design a system like that, you think I need a database where I need to be able to make 89 million requests per second. That's good. But remember, you don't have to go to 89 million. You can then scale to 0 the day after, right? You need that super elasticity, and that serverless design allows that super elasticity. Also, on the right-hand side of this slide, Amazon.com migrated from Oracle to DynamoDB for a bunch of back-end workflow processing systems, HERD, it's called. And what a great result. It went from processing delays from 1 second to 100 milliseconds, so faster performance, while the scaling and maintenance effort also dropped 10x, because it's something where you don't have to think about the database. You're not thinking about servers and replicas. It's just hidden from you. So the people who keep DynamoDB going worry about that, but you as a customer, it's not top of mind. As a result, we were able to retire 300 Oracle hosts and replace it with DynamoDB. So let me summarize. Serverless, unlimited scale up and down. Go for the peak, but then in the valley, it's fine too. Reliable single-digit millisecond latency for gets and puts, and very fast for the more fancy queries, even if you're going at millions of reads or writes per second and you're spiky. We call it a key value store. In many ways, it's kind of like a wide column store as well, though, because you can put anything you want in the extra attributes, and you do get global secondary indexes to provide an alternative view to things. Pretty straightforward API. If you can express it, it'll be fast. It has strong consistency or half cost eventual consistency. It has cross-region replication, ACID, streams, other features like point-in-time recovery too. Things it doesn't do, though, it doesn't do aggregations. You're thinking, oh, I want to count this. That's not a good DynamoDB use case. If you want to count, you probably want a Lambda that keeps track of the count and stores it back in the database for later retrieval. Because to do a count against large data, you can't do 89 million requests per second if you're counting large items, right? That's unbounded work. Doesn't do geospatial, doesn't do something like a full text. You integrate with other systems like OpenSearch for that. It does have like push button export test 3 if you want to do extra things. You want to do something like an analytical deep query against DynamoDB data, export test 3, run Athena, it works there. It has DAX as a caching layer in front, which is API compatible with DynamoDB. And that's great if you're thinking, I'd like to introduce a caching layer, but I don't want to rewrite my code. DAX, which stands for DynamoDB Accelerator, is a good thing to put in front. Same API, it's a write-through cache, and now you can boost your performance. And as a result, hundreds of thousands of customers have chosen to use DynamoDB, a bunch of logos here. I'm sure you interact with DynamoDB in your own life frequently every day. It's one of the core data services of AWS. It's a tier 0 service, which means that AWS itself uses DynamoDB for state maintenance, and a whole bunch of customers do as well. All right, let's talk about Amazon DocumentDB with MongoDB compatibility and look at a document-oriented database now as a different way of doing a NoSQL data store. DocumentDB is fully managed, but it does include servers. So you're going to be thinking about servers and sizes and counts. That's a differentiation from DynamoDB, but it is very highly scalable. You can get millions of reads per second because you can have up to 15 read replicas. On the primary, because there is only that one primary, you do have a more limited query rate or write rate, but it's still tens of thousands of writes per second there, and it'll scale up to 64 tibibytes. TIB, not terabytes, tibibytes. If you need to, you can scale out as well in minutes because it separates compute from storage. So you say, I need more capacity, it can give it to you. Some of its key features, it too has global replication, but in this case, there's one primary region and 5 secondary regions. So the secondary region are read only. The data propagates from the primary to the secondaries, all right? But they can be promoted. So if the primary region goes down, some sort of issue there, you want to move, all right, less than a minute, you can have a secondary region becomes a primary. The indexing is more rich than DynamoDB. It has VSON and JSON as data types, and you can query against things like nested fields and array fields. You can't do that kind of stuff with DynamoDB. It's so straightforward that in DynamoDB, you have to have anything indexed be a top level attribute. But here you can say, I want to index on that part over there, or maybe that part over there, and you don't have to change your data model to do it. It also has data streaming, so change streams are possible. You can observe the changes happening. It also has ACID transactions. single item always atomic, but you can now with 4.0 have ACID transactions that crosses multiple documents. And you can say, I need all these documents to change, and I need that update to be ACID. The schema is very flexible, differently flexible than DynamoDB. This one is flexible in that it's document oriented and not like Word files, more like JSON, things like that. So I can have any sort of JSON that I want to store as my item, and then I can index different attributes of that JSON document. Each one has a unique ID field that's like its primary key, and it can be auto-maintained for you can specify it. That's the ID that this document's going to have, but then you can query by attributes within the document. Its main, is it a feature, differentiator, is that it's API compatible with MongoDB. So that's great for customers that have existing MongoDB code, but want to go to a fully managed system. They want AWS to take over the management of it so that you can do push button, add a server, make it real simple, and you can get away from having to think about clusters yourself. All right, so anything you're using from the drivers and open source tools from the MongoDB ecosystem are useful here because it's API compatible. So, the expertise and the tooling you can bring here and keep your MongoDB workflow going. Its connectivity, it doesn't have a public endpoint. It's in a VPC, only available within that VPC, or you can do things like VPC peering. So that's kind of classic. It's servers that live within this VPC, and you have to be available within that VPC. So that's a security feature to be able to limit the view to within that VPC or anyone peered to that VPC. When it comes to pricing, all right, it's kind of what you'd expect. Compute instances, how much hardware are you throwing at this, priced per second running, how many seconds did it run, down to the second, as well as the data IO, millions of IOs that you go to the data storage subsystem, the storage size priced in gigabyte months, and any backups that you do priced by gigabyte months. So pretty typical. And when would I use this? Mostly, either want to do a MongoDB workload, I already have one, but I want to move to managed. I'd like to get away from the idea of managing servers. I want to store JSON documents, be able to do more robust things than DynamoDB offers, like aggregations or more ad hoc queries, or index on any key within the JSON document and not readjust my data. I want to use open source APIs. I want to not think like DynamoDB. It has a simple API, but it is only for DynamoDB. This is works for any MongoDB system. And Plume's a customer story here that I think is kind of interesting. They were built on MongoDB for smart home. It's been growing great. And they're thinking, all right, we have to add more capabilities. Do we want to bring on in-house database management expertise, or do we just want to keep developing and have someone else do the database management? And they chose to have AWS do the database management by using DocumentDB. And as a result, they're able to do 50,000 API calls a minute, and DocumentDB is not really blinking an eye, is the quote. And they can get away from the idea of, all right, we should figure out how to edit in a VI file, anything. A lot of different customers, including Amazon itself, for DocumentDB. There's a link here. Go to AWS-Amazon.com, DocumentDB customers, and you'll be able to read the use case stories behind each of these. So let's summarize. Fully managed document database, tens of thousands of writes per second, millions of reads per second with millisecond latency. Very cloud native, API compatible with MongoDB. Good if you have a MongoDB workload or other workloads that need document database features with all that flexible schema, flexible querying capabilities to index on anything inside the document. Still get ACID transactions, things like aggregations and geospatial available. It's more robust than DynamoDB in this way. It does only do read-only cross-region replication, not read-write on both sides. And you do have streams to observe the data changes, right? Hopefully that gives you a good summary of all the databases. So here's a bird's eye view of what we just covered, right? 4 different services, all managed, some server-oriented, some serverless. All of them are very high performant, but in different characteristics, and it depends on your definition of high performance, right? Is 10,000 writes per second high performance for your use case? Is 1 million? Is 100 million? Different databases have different limits there. Different APIs from Redis, and Memcache, MongoDB, proprietary, and particle, and then the categories. in memory, document, key value, sort of like wide column with DynamoDB. Extra stuff we talked about, the schema, all very flexible in different ways though, right? For the two I just talked about, right? One is a flexible JSON document. The other one is flexible because it's any attributes of any data type that DynamoDB supports, and each item could have a different one. ACID transactions available on the right-hand side, connectivity, VPC mostly, except DynamoDB has public or a VPC gateway. MemoryDB doesn't have global replication, the other do. DynamoDB, the only one that has active-active. Streams, Redis on the left, and multiple stream choices on the right. So hopefully this is a good summary for you. Are you ready for your quiz? All right, I'm going to quiz you. And note that, these are not the only criteria for picking a data store. There's a wide variety, but I want to say I have a situation where this, and what should I pick? So here's the first one. I need to create personalized customer experiences and manage user profiles and preferences with microsecond read and single-digit millisecond write latency. Microsecond read is, I think, kind of important there because not every database can do microsecond. Milliseconds, yes, but microseconds. So what's the one that would do microseconds? MemoryDB, good choice. It needs to be stored in memory, so I can do that ultra-fast performance. And MemoryDB also gives me the permanence to the data, right? It's not just purely ephemeral. I'm looking to query on nested fields or arrays, and I don't want to remodel the data. Well, as a DynamoDB solution architect, I oftentimes would say here, well, you can use DynamoDB, but if you want to get into something that's nested, you're going to have to bring that up to the top level. If you don't want to do that, DocumentDB is a choice because DocumentDB lets you index on something that's inside the JSON document. I need to use aggregations. Well, let's see. Caches wouldn't really work for that because they don't do that aggregation work. DynamoDB doesn't do aggregations unless you pre-calculated them. So which of the databases can do aggregations? DocumentDB. I want to run high concurrency streaming data feeds to ingest user activity and support trillions of requests per day. I bolded the word trillions. Trillions is a big number. Trillions of requests per day. Let's pick MemoryDB for Redis for that one, I think. It has ultra-fast performance. You can process more than 13 trillion requests per day and over 160 million requests per second because it's coming out of memory while still having persistence to the storage. I need to run ad hoc queries. The cache-oriented ones wouldn't fit. DynamoDB, you generally want to know your queries while you're doing the data modeling, and it's not just to say, hey, I invented a new query. So the database that's good at that is DocumentDB. It has that flexible join and aggregations and a query optimizer that will figure out the right index to use for the query. I want to build applications quickly using versatile data structures like streams, lists, and sets to build content data stores, chat and message queues, and geospatial indexes for demanding data-intensive web and mobile applications that require low latency and high throughput. Well, you're a very demanding person, aren't you there? What could I do with that? Geospatial indexes makes my, DynamoDB is not doing that. Versatile data structures, streams, lists, sets. Which of those databases had all those data structures I could use and yet still had really high throughput, low latency? MemoryDB, right? Persistence, ultra-fast performance, and all those Redis data types supported. I'd like to store large records and don't want to remodel and break them into smaller ones. Well, I could store large records probably in anything, and I could cache large records, but here we want to store large records. Could use MemoryDB, but I think what we're going for here is DocumentDB, specifically because it has a 16 meg limit on a document. DynamoDB has a 400 KB limit on a document, or on an item, I should say. If you want to store something larger in DynamoDB, you'd have to split it into separate items, or you can put it into S3 and point at S3 as an external reference to data, and people do that quite a lot. But if you want to have the larger document index on any attribute of the document, DynamoDB is a good fit. I want to build player data stores, keep session history and leaderboards for gaming applications that require massive scale, low latency, high concurrency for real-time updates. Well, assuming that we want persistence, we won't do ElastiCache, we do MemoryDB. Could I do DynamoDB for this? Yeah, I mean, I could. Is that what we're going to pick? No. I'm going to pick MemoryDB, mostly for the really low latency, right? Ultra fast performance. How fast do you want the performance? Because DynamoDB would be single digit milliseconds. MemoryDB would be microsecond oriented, right? And so they're different in scale and they're different in some performance characteristics of which one you'd want to use. I'd love to reduce the operational overhead of my self-managed MongoDB cluster, right? If you haven't gotten any right before now, hopefully you can get this one right. Yeah, it's the database that has the MongoDB API, right? Straightforward. If you want, sometimes people think, well, I'd rather go to some other database and I'm okay to change the API. But if you want to keep the API that you've already developed, that's fantastic for you. I want to stream data changes from the database. Oh, if you remember, the databases on the right-hand side, there were the ones that had this data capture. DynamoDB and DocumentDB both support this. I'm looking for a database with cross-region replication, which allows me to concurrently write and read across multiple regions. The difference here is that I want to write to both of them, right? Not just read, but write to both and have bidirectional synchronization. Only one database did that, which was DynamoDB. I have a spiky workload with potentially idle periods. When you're thinking about this, I have spikes and valleys. That's a good fit for which database? The serverless one, because you're not thinking about servers and counts and where you have to size anything. The servers are always there and you're charged for what you're consuming of that server pool. And it's not just devoted to you, so you don't have to pay for it when you're not using it. And especially when you're in on-demand mode, right? Super spiky, go down to 0, super spiky, back to 0. You don't have to pay for throughput when you're at the 0 level. I have a data set larger than 64 TB. Remember which database I mentioned that had the TB limit? That was DocumentDB. So DynamoDB does not have a limit in the data size. Customers go into the multiple petabytes of data. That's just fine. Millions of requests per second at the petabyte range. I have a workload with at least hundreds of thousands of writes per second. That's a good write throughput. Which of the databases was really optimized for that? The one I'm thinking of is DynamoDB here because it has practically unlimited write rates. So many servers on the back end to be able to handle the write rate that you're sending it. I'm looking for a high throughput of strongly consistent reads. All right, strongly consistent. One of the databases we talked a lot about consistency, that was DynamoDB. DocumentDB also has the ability to do consistent reads if you read from the primary. Okay, so with DynamoDB, you can have arbitrary throughput of strongly consistent reads. With DocumentDB, you can do it if it is able to be supported by the primary node. I use a relational database for my application, but as it grows, queries have gotten slower. And that's a pretty common issue. As your data grows, your user load grows, queries can get slower. What can you do about it, short of changing the database in some manner? A lot of people introduce a cache layer, and ElastiCache for Redis is a great cache layer to put in front, because the idea is that once you've done the retrieval from the database, you store the value in the cache. And then the next time, instead of going to the database, you can pull it straight out of the cache, and it can boost the performance tremendously, as well as sometimes reducing costs because you hit your database a lot less. It gives you sub-millisecond latency for anything that you've recently accessed. I have an application that was initially built for one region that has grown to have users around the world, and I'm seeing performance issues with read requests. This one's actually kind of tricky. Do you want to change the application? Like, are we picking a database initially, in which case we have a lot of choices? I can do DynamoDB, which has this active-active global replication. I have DocumentDB, which can have read replicas. In this situation, it sounds like you already have an application, was already built, deployed, and you're trying to say, how can I speed things up with maybe the minimum amount of change to existing code? For that, possibly a cache could work. ElastiCache has a global data store. You can have a read replica around the world. If you use this, you'll be able to speed up in other environments, even if you don't have a copy of the database in that other environment, even if you're using relational, you have possibly read replicas in other regions. You wouldn't have to necessarily replicate the core data. You just have a cache that's globally replicated. And someone in a different geography than where the database is can do a quick local check against the cache, possibly get a very, very fast answer if it's already been in cache. So that's the idea here. That ends our quiz. Hopefully you got all of them right. And we'll stay on the line here to do some Q&A with you. So feel free to ask questions. We'd love to answer them. Thanks so much.